Now we're ready to do some measurements, some real-time measurements. So we have already wired our sample to the proper connections, set the settings in the AD menu. So now we are good to go. So there are three different ways to acquire the signal synthesis system. One of them is in real time. Another one is a single shot. And a third option is a scan mode. So scan mode means the laser, you remember the laser point that I show you, can be rastered over a specific geometry, and you can define that geometry using some points, some predefined points. So for now, I'm gonna turn on my laser. So this bar over here is the signal strength. So you need a good signal strength coming from the laser in order to have a good measurement. Which means if you want to measure something with this LDV, it needs to be shiny. It needs to be coated with some sort of reflective material, either metal or some sort of reflective tape. Some people have tried to measure the carbon nanotubes. With it, it doesn't work because it absorbs all the light, and then that's the trade-off in this system. But it's very good. And so the way it's done is, if you do not remember, if you don't see the laser beam, or you cannot locate it, just hit this button, high contrast button, and now you can locate it. It's over here. And you can actually see the, my substrate is very reflected, so I don't see a variation in the strength. But you can raster whatever you want. Now, you disable this high contrast laser display, and now you can do measurements. So, let's start the real-time measurements. So, with this button.
One supplement. So, when you switch to high contrast mode, you will disable from either move your sample using the joystick or by double click. This function gonna be disabled.
Oh yeah.
And when you switch it back, the joystick will remain unchecked. So if you want to do a high contrast measurement, like within over different areas, remember to check the joystick box before the movement.
Yeah. Thanks for the add-on. Okay, so now let's gonna run a real-time measurement. So I'm gonna click start on the continuous mode. So once I click it, I'll see that so I have two analyzers, and so in this one I'm measuring the reference signal, which is our chip signal. I'm getting all noise because I have not enabled it yet.
It's not the same reference as this.
It's not the same reference as that. This is reference voltage. This is vibrometer displacement. So this is the real measurement I'm getting, and so it's actually in real time. So what I'm measuring here, what I am measuring here, it's real. So it's all background noise. You can change what you measure here if you want to see the time signal or the FFT directly. And same case here, the time signal or the FFT directly. And you can see you can change what measurement you want in each of these analyzers. If you need an extra analyzer, you can have one more by hitting this button like new analyzer. But for this measurement, we only need two. Now, this is in real time, and now, yes, so I'll explain that to you in a second. So right now, the function generator is disabled. I'm gonna enable it, and now this is the chirp signal I am sending to my device, and now I'm still measuring noise. That's mainly because my laser beam is focused somewhere else. You see it's over here, and I want to measure the vibration on each of these samples. So let's drag it along here. Let's see if I get better measurement.
Wow. Did you check it's on the velocity analyzer or displacement one? No, I mean not
This
the
is-
micrometer. I mean on the tab there.
Yeah, it's displacement. So remember the bandwidth of the decoder. Even though I'm measuring up to 20 megahertz, I don't need it because the resonant frequency of my device is around 2.5 something, 2.7 I believe. So what I can do is in real time, you open up this dialog, and you can actually modify the frequency. So now,
It's real time? Or
yeah,
continuous?
yeah. So I think it'll partially stop. So it'll stop, and then you can select lower frequency. Let's
Or
say
you
I'm
click
gonna
the A to D settings
Yeah.
again?
8D settings again, and now I'll click. I'm gonna measure up to 5 megahertz now. Where did it go? Oh, hold on. Oh, sorry. From 0 to 5 megahertz. There you go.
Yeah, I have to.
Yeah. Yeah. When you have another range, you very often have like a peak at like a very low frequency, so you can get rid of that. You can go from 0.01 megahertz to 5 megahertz, and you get rid of the initial peak. If that still doesn't work, you can go even higher than that. Now, the signal looks a little bit choppy, so you can increase the number of FFT lines in here. Let's go to 3200, and now you should get a better measurement.
And also average time.
Yeah. So that's in real time the measurement of your sample, and now I can tell you that these guys are oscillating at 2.6 megahertz. So they are vibrating up and down at 2.6 megahertz.